question 22, triangle ABC and A prime, B prime, C prime are drawn the grid. So you can see the two triangles there. So let us go to the first question. Describe fully a single transformation that maps a triangle ABC onto triangle A prime, B prime, C prime. So you can see the two triangles. So triangle ABC is here, and then it is mapped onto these. So you're actually required to describe a single transformation that maps this triangle here, smaller one, to this one. So think of all the transformations, but the one that is evident in this question, because you can see the change in size, is actually enlargement. And that is actually the transformation, because you can see triangle ABC is small, and you can see triangle A prime, B prime, C prime is a larger one. So it has been enlarged, and therefore the transformation is enlargement. Now, how do you describe an enlargement? You describe an enlargement fully by giving the center of enlargement and the scale factor of the enlargement. So how do we get the center of enlargement? We begin with that. Now, the first thing we're going to do is joining. You can join, you can say to join either point A, you join it to A prime, and then you can decide to join B to B prime. So let me start by joining A to A prime. So joining A to A prime. So you have A is there. So I join that one to A prime like that. And then I join, or I can join even C. You can choose any point that you wish. I can even decide to choose C. So let me choose C to C prime like that. Now, where those lines meet, that is the center of enlargement. The two lines connecting from an object point to the image point. So I've joined A, that is the object point, to A prime, that is the image point, and then I've joined C to C prime. So that is the object is C, image point is C prime. Where the two lines are meeting, that is the center of enlargement. So the center of enlargement is the origin, which is O. Now from there, let us get the scale factor of enlargement. Scale factor of enlargement. So how do you get the scale factor of enlargement? Now, to get the scale factor of enlargement, you can get this measurement from C, for example, from C to O, and then O to C prime. So I'll take this distance O, I'll take the distance O to C prime divided by OC. Or you can take OA prime divided by OA. Either of these will give you the scale factor of enlargement. So I'll use this distance O to C prime, O to C prime. That is what I'm going to use. So O to C prime, this is the distance. So from this point to this point. So you can take that measurement. You can use a ruler to do that. So let me take that measurement. So I can see that is 3.4. That is 3.4 according to my measurement here. OC prime is 3.4. And then I take the other measurement, OC. So O to C is this measurement. So from this point to this point, I can see that one is 1.7. So divided by 1.7. And this one gives you 34 divided by 17. It will give you 2. So that is actually the scale factor of enlargement. Now, the other thing that you need to notice here is that the scale factor of enlargement will actually be negative. Why will it be negative? Because in negative enlargement, the object and the image are on the opposite sides of the center of enlargement. So look at the center of enlargement. The center of enlargement is the origin, it is here. Then the object and the image are on the opposite sides of the center of enlargement, and that one is why we give the scale factor of enlargement as negative. If the object and the image are on the same side with the center of enlargement, they are on the same side, that is the center of enlargement, the object and the image. If you find them on the same side, that is positive enlargement. But in case you find the object and the image are on the opposite sides of the center of enlargement, then that one is definitely the negative scale factor of enlargement, and therefore this one is -2. So now we can describe that. So this one is an enlargement. That one is an enlargement. Center is the origin, and then the scale factor of enlargement is -2. That is the full description of an enlargement. Now you can go to the next one. The next part is on the same grid, that is part B. On the same grid, draw one triangle A double prime, B double prime, C double prime, the image of triangle A prime, B prime, C prime under a rotation of +90 about the origin. So now we're supposed to get the image of A prime, B prime, C prime. So when you go to the diagram, I will first need to clear this. So I will clear this one so that I can now rotate. So you're required to actually rotate this one, A prime, B prime, C prime, under a rotation of +90 about the origin. +90 about the origin. So how do you go about that? I'm going to use a protractor, and I'll use a ruler and a pair of compass to do that. So the first thing you do, you're supposed to join every point to the center of rotation. The center of rotation is the origin. So I'm going to begin with A. So point A is there. So begin with point A. I join it to the center of rotation. Then from there, +90 degrees. I want to rotate that through +90 degrees. So I'd like you to observe how I'm going to place my protractor. So on that line, that you can ensure that the central part of the protractor is the origin there. And then look at the way this protractor is supposed to be aligned like that along this straight line, like that. So that is how you place it, and actually ensure that this is the central part of the protractor. This is a straight line. Then +90 degrees, you're going to measure that one in anti-clockwise direction. Anti-clockwise direction mean you're going to measure it from this way, from this point going this way up to 90 degrees, like that. So you measure 90 degrees. So this is what I'm going to draw. So 90 degrees, you can see that is 90 degrees. You measure 90 degrees, so that is 90 degrees. You can see that this point here. So from this point 0 all the way to 90, that is anti-clockwise. That is +90 degrees. That's how you measure it. So you draw that line there. So this is 90 degrees. Then from that, this is what you do. Now you need now to take a pair of compass and take this measurement. So from A, you take that measurement A to the center, that is to the origin, the center of rotation. So from A, you take that measurement. So take that measurement there. So take that measurement from A to O, and then transfer that one to, you started that O, and then you transfer that line that you've drawn there and C. So that is where you're supposed to, mark an arc. So that is there. So that is just a small one that you mark that. And these will be A double prime. So these will be A double prime. Now we go to B, join B to the origin, using a straight line. So B to the origin, like that. And then from there, you measure 90 degrees. So this is how you place your protractor, the central part of the protractor. And then you place it along that line, and ensure like that. So that is, I want you to note how you place that. So you can see how I've placed the protractor, the central part of the protractor is there. So you measure 90 degrees. So measure 90 degrees, and you draw, so 90 degrees. So you can see that is actually 90 degrees. Measure 90 degrees. So this is the angle from this point, or that is +90 degrees. Then from there, the next thing you do is actually taking the measurement. Take this measurement here. So take this measurement from B to the center, that is from C to O, from B to O, take that measurement, and then transfer that measurement, stand at the origin, and then you transfer that measurement there. So you mark an arc. So that will be point, or the image of B, that is B double prime. So this will be B double prime. You can see this distance, B to O, that is the distance you've taken, and then you start at this point to B prime. So for A, we took this measurement from O from A to O, and then we transfer that distance. That is the distance there we marked A. So the last one is C. The last one is C. So from C to the origin, you join that. Then from there, you measure these, place your protractor and measure 90 degrees. So you can see the way I've placed it. So I've placed it, this is a straight line there. I want to measure now 90 degrees from this line, 90 degrees, 90 degrees. So measure 90 degrees. So from that point, so 90 degrees is there. So that is 90 degrees. Now this angle here, what is that? This angle from this point all the way to that line, that is a line 90 degrees. So once you've done that, now it's time to take that measurement. Take that measurement. So you take this measurement from C to O, from C to O, from C to O, from C to O, and then you transfer that. You transfer that by marking an arc there. So you've taken that measurement. So the measurement is here. You've taken this measurement C to O, then you've transferred that. So this is the image of C. So this is C double prime. So now you have the 3 points. So you have A double prime, B double prime, C double prime. You can join them to make that triangle. You can join them. So from A to B, and then from B to C, and then from C to A. So that is the image. You've done that. So we've now given a triangle A double prime, B double prime, C double prime. The triangle is there. 2 marks. We go to the next part. The next part is a triangle A triple prime, B triple prime, C triple prime. The image of triangle A double prime, B double prime, C double prime, and a reflection in the line y is equals to negative x. Now that triangle that we've drawn, this triangle, I can name this triangle for the purposes of identification. So I can name this triangle A, this being triangle B, and this triangle C. So triangle C, that is triangle A double prime, B double prime, C double prime. You need to get the image of that and a reflection in the line y is equals to negative x. So y is equals to negative x is this line that passes through this point. Let me draw that line. Y is equals to negative x. Y is equals to negative x. We have this line that passes through this point. That is the line that passes through the center of the axis. So this is actually y. This is y is equals to negative x. So you need to give the image of that, and this is what you're supposed to understand. Before you draw that, there's one thing that you need to understand, that under a reflection in the line y is equals to negative x, if you have the object point as AB, that point you get the images as negative B, negative A. So the points are reversed and they also change the signs. So it is easy to get the images of these points. So under that, A double prime is this is 8, 2, 8, 2. So that one becomes A triple prime, that becomes negative 2, negative 8. Then for B double prime, B double prime is a 6, 6, 6, 6. So that one B triple prime, so that one B triple prime becomes negative 6, negative 6. The points are reversed and they also change the signs. Then for C double prime, we have 2, 4. That is 2, 4. That is 2, 4. And that one becomes negative 4, negative 2. Now having that, we can simply now plot them to have that triangle. So for A triple prime, negative 2, negative 2, negative 8. So negative 2 is here. Then negative 8 will be here. It will be here. So this will be A triple prime. And then for B, negative 6, negative 6 be here. This is B. And then for C, negative 4, negative 2. Negative 4, negative 2. So this is a C triple prime. So now we can join them. We can join them. So we have A dot B, and then from B to C using a straight line, and then from C D. So that is a triangle. Actually, you can see now the object and the image. You can see. So this is the triangle. After it has been reflected in that line, y is equals to negative x, we get it here. So that is basically how you're supposed to solve that part. We go to the last part. Draw the line, that is part C. Draw the line of symmetry of triangle A prime, B prime, C prime, and hence Determine its equation in the form y is equals to mx plus c. Draw the line of symmetry of triangle A prime, B prime, C prime. Which triangle is that? It is this triangle. This triangle. Draw the line of symmetry. The line of symmetry is the line that divides that triangle into two equal halves. And when you look at this triangle, you notice that it is isosceles. It is isosceles. So this side is equivalent to this side. And therefore, to divide it into two equal halves by that line of symmetry, we will need to get the midpoint of AC. Get the midpoint of AC. So the line that will pass through the center at this point, So the midpoint, we need to get the midpoint of A prime, C prime. So I will take that measurement. I'll take that measurement using a ruler so that I can know exactly the midpoint. And me take the measurement and take that measurement. So that one is around 4.8. 4.8. That is 4.8. So therefore the midpoint will be, that will actually be 2.4. So 2.4. So 2.4, let me draw that line. So 2.4. So from this point, here, so from this side, so from this point, I will have to draw, me check first. So from this point, so I will need to mark 2.4 here. Let me mark 2.4. So 2.4 is here, somewhere here. So I will need to draw a straight line using a ruler from this point C. So let me first clear. I'll need to clear these. I need to clear something here. Or I can just continue with that. I don't think there's any problem. I can just continue with it. So I actually want to draw the line. So from this point, so that will be the line of symmetry. That will be the line of symmetry. So what I've done, I've actually taken the measurement. So these are this point. So these A prime to C prime, I've got them to be 4.8. I've taken the midpoint of that is 2.4, and this one is 2.4. So because this one is an isosceles triangle, if I draw a line from this point straight, it will divide that triangle A prime, B prime, C prime into two halves. So you can see this triangle has been divided into two halves by that line. So there's this half on this side and there's this half on this side. So I've just taken the midpoint of this line, A prime, C prime, because this side and this side is equal, and it is an isosceles triangle. So that is the line. So this is the line of symmetry. Now what we require to get is the equation. We actually need to get the equation of that line. So to get the equation, we actually need just 2 points, on that line, and identifying these points is very easy. So you have the first point is here. This is point B, which is a 6, negative 6, 6, negative 6. And then I have another point here, this point, just 2 points on that line, any 2 points. This is 0, negative 4. So this is 0, negative 4. So these 2 points can help me get the equation. So I start by getting the gradient. The gradient of that line will be given by change in y, which is negative 6, subtract negative 4, divided by change in x, 6, subtract 0. So this will be negative 6 plus 4 divided by 6, and this will be negative 2 over 6, which is negative a third. So negative a third is actually the gradient. Now having the gradient, I can simply use the gradient, and I can introduce, I can simply use 0 and negative 4, and then I introduce another general point on that line, x, y. So I have the gradient, which is a negative a third. So change in y, so y subtract negative 4 divided by change in x, x subtract 0 is equals to negative a third. So this will give y plus 4 divided by x is equals to negative a third. Is still moving on. So this will give, if you cross multiply, you get 3 multiplied by y plus 4 is equals to negative 1 times x, that is negative x. So this will give 3y plus 12 is equals to negative x, like that. And then supposed to give the equation in the form y is equals to mx plus c. So therefore 3y is equals to negative x, subtract 12. So divide both sides by 3, or each value by 3. Y is equals to negative x over 3, and then subtract 4. 12 divided by 3. So that is the equation of that line of symmetry in the form y is equals to mx plus c. And that is how you're supposed to solve that question.